Hello, how are you? I hope you are doing well in your organic classes. Today we are going to address an important reduction reaction known as Birch reduction reaction. Previously we have focused on reduction of alkenes and alkyne with a specific emphasis on hydrogenation in the presence of metallic catalysts. So today's topic addresses Birch reduction reaction, which is an important reduction process in organic synthesis. Basically in Birch reduction reaction, benzene are substituted aromatic hydrocarbon are transformed into a cyclic 1,4-diene. While we are dealing with organic chemistry, we usually come to know about a kinetically controlled and thermodynamically controlled product. The question may rise here that for example a Birch reduction reaction focus on formation of 1,4-diene. Why not it should be a conjugated diene? Because conjugated diene are more stable as compared to that of isolated diene. So in Birch reduction we get an isolated diene, not a conjugated diene. Those products which are governed by rate of a chemical reaction, are they form at a fast rate, so they are kinetically controlled, while those products which form at elevated temperature they are more stable, so they are known as thermodynamically controlled product. So in Birch reduction reaction the product usually form in a kinetic control rather than a thermodynamic control way. So Birch reduction reaction give rise to formation of an isolated diene rather than a conjugated diene. Birch was basically an Australian chemist who proposed this reaction in 1928 by reacting benzene or its derivative in the presence of reaction medium that was facilitated by sodium or lithium in liquid ammonia in the presence of alcohol. So these are reagents which are used for executing Birch reduction reaction. Here we have shown simple examples such as benzene is transforming into a 1,4-diene or cyclohexane 1,4-diene, which is a cyclic diene, and this is an example of isolated diene, not a conjugated diene. For example, if the double bond was here, so we will call it a conjugated diene rather than isolated diene, but actually in Birch reduction reaction we get an isolated diene rather than. So this is a very important point to realize with respect to this reduction reaction. The mechanism is quite simple and it takes in few simple steps. Just focus on the mechanism. The first step is, you know that whenever sodium is made to react with liquid ammonia, it give electron and give rise to formation of sodium ion. This electron is solvated. Once this electron is shifted into a solution, it turns the solution into a deep blue color. So this is one of the indication that no, the ammonia solution has a solvated electron. So once the solvated electron are obtained, then the actual reduction process takes place. Just we will look here in mechanism that in first step electron adds into an aromatic ring. Basically we have shown the movement electron with the single fish hook arrow, which is used for movement of single electron rather than moving a negative charge or two electrons. So if there was a complete movement of a negative charge, then at that moment we will have to write a complete arrow. So this distinction must be clarified and keep in mind while writing a correct mechanism in organic chemistry. So once the electron is added in the first step, it gives rise to formation of a radical anion. Here the addition of electron is also governed by corresponding movement of a pi electron as well. So once this process takes place, the addition of electron takes place, it gives rise to formation of a radical anion. Why we call it radical anion? Because this complex or intermediate complex has a radical as well as a carbon ion. So that's why it is known as radical anion. In the next step, the negative charge abstracts proton from the alcohol, or in other words, alcohol protonates the negative charge and give rise to formation of a radical. Again, that radical is reacted with another electron for giving a carbon ion. So once this the second carbon ion is obtained, it is protonated again for the second time and ultimately gives rise to formation of a product known as 1,4-diene. Here are two important cases with respect to Birch reduction reaction. For example, here we have focused on a simple aromatic compound such as benzene, which is a starting member, but if the aromatic compound are substituted, we have studied that the group on the benzene ring can either be electron withdrawing or electron donating group. So if we are performing a Birch reduction reaction and the starting material has some electron withdrawing group such as carboxylic acid or carboxyl group, so the reduction gives rise to formation of a diene in which the carbon bearing the carboxyl group is reduced, or in other words, this ipso carbon atom has reduced. But if a group which is electron donating in character, then in Birch reduction reaction we encountering a situation where the ipso carbon is not reduced. So if we explain this distinction, that is being distinguished by electron donating or withdrawing group, that why in one case the ipso carbon bearing electron withdrawing group is reduced, while in other case where there is electron donating group is not reduced. So the point is that electron withdrawing group stabilize carbon ion. So throughout the ring, if you look at a mechanism, throughout the ring the negative charge, whether it form here or in any 5 carbon atom of the ring, will not be as much stable as in the case on the ipso carbon atom. Why? Because the negative charge is stabilized by electron withdrawing group. So that's why here when the negative charge is formed, definitely it will abstract proton from the alcohol and this carbon atom will reduce. But as far as the electron donating group is concerned, it destabilizes carbon ion by positive resonance effect or positive mesomeric effect. So that's why the carbon ion will resist to form at this carbon atom. So if there is no chance for formation of carbon at this ipso carbon atom, so definitely there will be no reduction of this carbon atom. So this is a simple point which need to be realized, that why electron withdrawing or donating group give a different dienes. There are some important features with respect to Birch reduction which should be memorized or it should be kept in mind before addressing the Birch reduction reaction. So these point includes that Birch reduction is basically a partial reduction of arenes or aromatic compound. It is partial reduction, not a complete reduction. Secondly, the alcohol serve as a co-solvent. I mean that the alcohol act as a co-solvent. It has an important function. It assists the solubility of the aromatic compounds. It acts as a protonating agent. We have seen in the mechanism that it protonates the carbon ion. It helps in protection, or it acts as a protecting group as well. Why? Because it stops the formation of amide ion. Otherwise, if there is a formation of amide ion, it will isomerize 1,4-diene to 1,3-diene. So these are some important aspects of the solvent, which is alcohol in this case. The third important aspect is that Birch reduction is third order or third degree reaction. It is first degree in alcohol, first degree in sodium or alkali, and first degree in arene or aromatic compound. So as a whole, the reaction is a third degree or molecular reaction. This reaction is kinetically controlled, and all those reactions which take place at low temperature, they give a kinetically controlled product which are unstable or less stable as compared to a thermodynamically controlled product. Why? Because thermodynamic controlled product are obtained at high temperature, but as far as the Birch reduction is concerned, the reaction is usually performed at low temperature. So that's why the product obtained in this case is kinetically controlled. Moreover, Birch reduction is regioselective. So when the first proton is added, the second proton always add to the para position. Okay, the second proton always add to the para position. For example, first proton added here, the second proton added to this position which is para. So that's why we call it a regioselective reaction. So this is all about Birch reduction reaction, which is an important continuation of reduction reaction in organic chemistry. So hopefully, inshallah, we will focus on more organic reaction in our next lecture.